Okay. So the first problem, let us read the problem thoroughly. What is the probability of getting one head? Now, when they're talking about head, then it is about the coin. So they will ask you what the one question, one major question, along with 2 to 3 sub questions like this. So remember, what is the formula to find the probability? The major formula to find the probabilities will be using this method mostly in all the problems. Okay, so that is favorable number of cases to that particular event or the question divided by exhaustive number of cases. So in this question, let us understand, when a one coin is tossed, what is the probability of getting one head? So when you toss a coin once, what can be the outcome? That is the sample space. S is the sample space. Either you can get head or you can get tail. This is the possibility when you toss a coin. And what is that they have asked us to find? They have asked us to find the probability of getting one head when we toss one coin. So we have to define an event, that is A is the event of getting one head. Okay, so what should be the answer for A? A is the event of getting one head. We are tossing one coin and we are supposed to get head. That should be the result. Now, the possibility of the answer is 2. You can get a head or a tail. But out of the 2 possibility, what have they asked us to find? They have asked us to find about only one head. Okay, so this is the favorable outcome of the event A, and this will be the exhaustive outcome or the sample space. All possibilities together are called as exhaustive sample. And when it comes to the outcome of an event, it is the favorable outcome. Okay, so what is the probability of getting a head when you toss one coin is nothing but probability of the event A. What is event A? Event A is getting one head. Okay, and the formula goes like this: N of A by N of S. So the favorable outcome, that is getting of one head, is only one. So that is why we write 1. And what is the possibility, all possibility of getting the answer? When you toss a coin, what is the possible answer that you will get? You can get either a head or a tail. So head is one answer, tail is another answer. So there are there are two total outcomes. Out of two total outcomes, one only I want as the result, that is head. So 1 by 2 is nothing but 0.5. So there is somewhere around 50% probability of getting head when you toss one coin. Did you all understand this first question? Everybody understood? Or you want me to repeat it again? I appreciate it if you reply it in the chat box quickly. Okay, good. Now, let us go to the next question. Next question means in this only sub question. What is the probability of getting one head? Now, what was the first question? When only one coin was tossed, what will be the possibility? Now we are tossing two coins. Okay, now here it was only one coin, so only head or tail. Now we are tossing two coins. Okay, I will make two people stand here. Let us say Akhila and Bhavana are standing here. Okay, Akhila and Bhavana are standing here and they are tossing the coin. Okay, now what are the possibilities I can get? Now Akhila can get head and Bhavana can get tail when they toss the coin. Now, second possibility, Akhila can get head, Bhavana also can get head, right? Akhila can get tail when she toss it again. You're tossing it continuously, right? So, and Bhavana can get heads, and both of them can get the result as tail. So, what are the possibilities I got? Head, tail, head, and tail, head, and then tail, tail. So these are the four possibilities that can come when I toss two coins continuously. Understood? This is how you find out the sample space. Can you all hear me?
Okay, good. I hope it is much clearer now. Okay, now since the overall answers should be within this four options only, now let us read the question. What is the probability of getting one head? So what should be the event? Event should be getting one head. Now in which all these places have we got one head? Now see here, one head. Here both are heads, but there is one head which is applicable. Okay, they're not considered that one head. So what we will do here is, now head and tail and head. Head, tail, tail, head. In these two cases, we are exactly getting one head. Okay, so out of total four results that might come in this experiment, for me what is favorable is two cases. So probability of the event A, what is the event A? Event A is getting one head. Okay, now here also I am trying to get one head. Here it is two heads, so we are not considering. Here it is two tails, so we are not considering these two. So but the other two, there are only one head. So there are two cases out of four cases where we have one head that has been considered. So there is again 0.5 as the probability. So that is nothing but 50% of the probability. Understood? Understood the sub question? Any doubts in the first question here? You want me to repeat any of it again? No? Yes, no? Reply something quickly. Okay, good. Now, next question. A uniform dice is thrown at random. Find the probability that the number on it is, first question is 5, greater than 3 is the next question, even numbers is the next question, and multiple of 2. Now before getting into the sub questions, let us understand the main question. The a uniform dice, now dice will have 6 numbers, correct? 1, 2, 3, 4, 5, 6. So when we roll the dice, we will get a number at random. Now they are asking what is the probability of us getting the number 5. So the easy way to solve this is first find out the sample space. Now sample space is the possibility of getting the outcome. What all outcome might come when I throw a dice. Now when I throw a dice, the possible outcome may be I can get 1, I can get 2, 3, 4, 5, 6. So this will become my sample space where how many numbers are there? 6 numbers are there, right? So my n of s, the number of sample elements that are there are 6. I'm repeating it again. Please listen carefully. Since it is a dice, you would use this dice to play snake and ladder, ludo, and many other games. So this dice has 6 numbers on it. So the sample space, the possibility of me getting the answer is in between these 6 numbers only. So that is the reason the number of outcomes that I can get is 6. So n of s in all of the cases will remain as 6. Okay, so this is one thing which you'll have to first derive and understand. Now, after this, let us go on and define each of the event. So it is easy for us to solve the events. So each sub question will be rearranged as an event. So for what is the first sub question? What is the probability that the number on the dais will be 5? So the event A is getting number 5. Now what will be the event B? Event will be is getting the number greater than 3. Okay. Event C will be getting even numbers. And event D will be multiple, getting the numbers which are multiple of 2. Okay. Now after defining the event, let us solve one by one. For the first event, where we are getting number 5, now we are throwing one dice. If you see the question, a uniform dice, a means one dice is thrown, and since there is only one dice is thrown and they're asking us what is the possibility of getting 5, there is only one possibility of getting 5. Okay, out of the chances that we have taken, there is only one possibility of getting 5. How did I get to know that one possibility? Because there is only one number. Okay, so n of a is equal to 1. I am supposed to get 5 when I roll the dice. So how many results are there? There is only one result. Okay, there is only one result. So that is why n of a is 1 and sample space is 6. So n of s is 6, and we understood the probability of getting 5 is 0.1667. So this is the first sub question. Did you all understand? Any doubts in the first sub question? Want me to repeat any part? Good. Now, moving on to the next sub question. The next sub question is talking about the numbers greater than 3. Now, which are the numbers greater than 3? We will analyze. So, out of the 6 possibilities that we have, that is 1, 2, 3, 4, 5, 6. This 4, 5, 6 are the numbers which are greater than 3. Correct? So the possibility B is the event of getting the number greater than 3. Now the possibility of getting the number more than 3, which means there are three possibilities. You can, once you roll the dice, you can get 4. 4 is a number which is more than 3. You can get 5. 5 is also a number which is more than 3. You can get 6, where 6 is also a number which is more than 3. So the number of result for the event B where you are getting the number more than 3 are 3 different possibilities. Okay, so you can get 4 one time, you can get 5 one time, and you can get 6 one time. So there are totally 3 possibilities which you can get from where when you get the number greater than 3. So n of b is equal to 3 and sample space is already 6. So 3 by 6 is equal to 0.5 is the probability of getting the number greater than 3. Okay, so this is the second sub question. Any doubts in the second sub question? Good. Now moving further, we have the third sub question, that is when we get even numbers. Now out of from 1 to 6, how many even numbers are there? We have to find out. Now from 1 to 6, how many even numbers are there? How many even numbers are there? C is equal to 3 even numbers. Good. So what are the even numbers that we have? 2, 4 and 6. So when we roll the dice, how many possibilities are there for me to get the even number? So once if I roll the dice, I may get 2. Second time when I roll the dice, I may get 6. Third time I roll the dice, I may get 4. Okay, so there are 3 possible answers that I can get for the even number. So n of C is equal to 3. And the sample space is 6 already. So therefore 246, to get 246, this is 3 possibility. So 3 by 6 is equal to 0.5 is the probability of getting the even number when I roll a dice. So this is your sub question number 3. And finally coming to the last question, that is multiple of 2. Now this even number and multiple of 2 is very similar in this question because it's a dice and only one dice is rolled. So if you see the fourth question, we are supposed to find out the multiples of 2. Now if you see, 2 ones are 2, 2 twos are 4, 2 threes are 6. Again you will have 2, 4 and 6 as the event where they are getting a number multiplied by 2. So I have 3 possibilities again where I can get the even number. So once I can get 4, the next time I can get 6, and the next time I can get 2. So there are 3 possibilities out of 6 different answers. So again, n of d divided by n of s is equal to 3 divided by 6 is equal to 0.5. So 0.5 is the probability of getting the multiple of 2 when you roll a dice. So this is your problem number 2. Understood? Any doubts in this problem? Anybody has any doubt? Everyone understood? Can we go to the next question? Good. Now, yesterday we understood the types of cards, right? The types of cards, I also even explained you along with the diagram. Now, there is a question regarding to the cards. So let us see how to solve this. Now, a card is drawn from a pack of 52 playing cards. So we understood there will be 52 playing cards where they will have heart, diamond, spade and club. So 13, 13 in each pack, and we have 52 playing cards. What is the probability that the drawn card is a spade? Okay, it's not space, sorry. It is a spade. It is D. Okay. What is the possibility of getting a spade? Now, we understood that we will have 52 cards. In that, we will have red cards and we will have black cards. Correct? And then in this also again we will have the bifurcation where we will have hearts and diamonds in red color and spade and club in black color, and for each of them we will have 13 cards where the numbers start from A, then 2, 3, 4, 5, 6, 7, 8, 9, 10, and then J, K, Q, Joker, Queen, King and Queen. This will be the numbering on the card. So this is what we understood from the previous class. Now today they are asking us what is the probability of drawing a card. Now so randomly I will pick a card from 52 playing cards, and what is the possibility of me getting a spade? Okay, spade is something like this, ulta heart and then you have a stand. Okay, that is spade. Now what is the possibility of getting a spade? Now before finding out the possibility of getting a spade, we have to define the sample space. What is the sample space? The sample space for a spade, now here sample space will differ because this card has so many varieties of things to be done, right? Now for every pack of card or every set of card, it's not pack, it's called a set. Every set of card, the numbering will be A to J, QK or JKQ, right? So this will be the sampling of the sample size of the card. Now what happens out of what are let's read the question once again. A card is drawn from a pack of 52 playing cards. So totally 52 cards are considered and one card is randomly picked. So 52 should be your total number of cards or total number of possibilities. Okay, so 52 is your total number of exhaustive events. Now out of 52, if I draw one card and if that card has to be spade, then I have 13 possibilities of taking a spade card. I can take a spade card with A or with 6 or with joker or with queen or with king or 8, 9, 7, 3, 4, 2, everything. I can select any one card from these numbering. Okay, but how many spade cards are there? There are 13 spade cards out of 52 playing cards. If I want to select spade card, then I have 13 possibilities of selecting it. Understood the first question? Understood the first sub question? How do you get a spade card? Or you want me to repeat it again? The second question is getting queen. Now, each card, okay, each set of cards will have a queen, correct? In spade you will have a queen, in clubs you will have a queen, in hearts also you'll have a queen, and in diamonds you'll have a queen. So how many queens are there in the 52 playing cards? You have 4 queens. Okay, there are 4 queen cards, and there are 4 possibilities of you drawing a queen card when you are picking from the 52 cards. So the total number of cards will remain still 52, but out of 52 there are only 4 queen cards. So there are 4 possibilities of you taking the queen cards. So every set will have a queen card. So here P of Q, that is Q is the queen, is equal to, there are 4 queen cards divided by total number of cards, which is 52, and the probability is 0.0769. Okay, so this is the second sub question. Understood? Okay. Now the next question is red colored card. Now, if you see red colored card, there are 13 heart cards and there are 13 diamond cards which are red in color. So 13 plus 13, you will have totally 26 cards which are red in color. So out of total 52 cards, there are 26 cards which are red in color. So that is why 26 divided by 52. Understood? So that is the red color card. Clear? Understood the third sub question? Now, the next question is just says color card, because just if it is color card, we cannot find anything here. They have to be specific about what color the card is, and only then we'll be able to find, because black is also a color, red is also color. Now, let us take this question as black card. Now, can you say me what will be the probability of selecting a black card? Anybody can answer. What is the probability of selecting a black card? How many black cards are there? Can you all hear me? Hope everybody is clear with this second question. So even for black cards, the answer will be same, that is 26 by 52, which is 0.5. Now moving on to the next question. A bag contains 5 red and 6 yellow balls. A ball is drawn from this bag. What is the probability that it is red? That is the first question. And what is the probability of selecting a yellow? Whenever you have such questions where it is in a bag or it is in a box, okay, apart from your coin and dice and cards, if you get any of such questions, then please use the combination. Okay, so combination will give you the answers more clearly and easily rather than using any other theorem for this. So let us understand the question clearly. There is a bag which contains 5 red and 6 yellow balls. Okay, so there are 5 red balls plus there are 6 yellow balls. So totally how many balls are there in the bag? There are 11 balls which are there in the bag. Now randomly they will pick one ball from the bag, and that ball, yeah, uh, correct. Now that ball should have, what is the probability of that ball being a red color is the first question. And again, if we randomly pick a yellow color ball, okay, sorry, if we randomly pick another ball, what is the possibility of it being yellow? So that is the next question. Now, firstly, we have to find the total number of balls, that is 11 balls. Now, this will be your total number, that is n is equal to 11. Okay. Now, what is the first question? What is the probability of choosing a red ball? Now, how many balls are there in red? There are 5 balls in red. So the chance of choosing the red ball is, out of 5 balls, we can choose one ball. This is the possibility. And out of 11 ball, we are choosing one ball. Okay. Now, why are we giving this is, that is how the formula of the combination fits in there. So out of 5 red balls, we are selecting one ball. That is the smaller scenario. Now, if you see a bigger scenario, there are totally 11 balls, and then out of that, we are selecting only one. Okay. Now, in combinations, whenever you have NC1, the answer is N. Remember this. Okay, whenever you have NC1, that is nothing but N. Now here you have 5C1, which is nothing but 5, and 11C1, which is nothing but divided by 11. So you can divide this and write it in the decimal format, or you can leave it until here saying the probability of getting the red ball from the bag is 5 by 11. Did you all understand? Okay. Now, similarly, if you want to buy yellow, if you want to select yellow color ball, now again, randomly, you are picking one ball from the bag. And if it has to be yellow, then how many yellow balls do we have? We have 6 yellow balls. Out of 6 yellow balls, we'll be selecting one ball. Again, there are total number of balls, that is 11. Out of that, we are taking one. So 6C1 is 6, 11C1 is 11. So the probability of getting yellow ball is 6 by 11 and red ball is 5 by 11. So this is the next question, very easy one, but you just have to know how to apply the combination. Clear? Can we go for the next question? Or you want me to repeat any part of it again? Any doubts? Reply quickly. Okay, good. Now, there is another question which is similar to the question we just solved. Okay, let us see what is this question saying about. Now, here, a bag contains five red and 3 blue balls. Now, here, the bag has 5 red and 3 blue balls. So what is the total number of balls that are present? How many total number of balls are present? 5 red and 3 blue. So which is nothing but there are 8 balls totally in the bag. Then 2 balls are drawn from this bag. Now in the previous question only 1 ball was drawn, but now 2 balls are drawn randomly. And they're asking us what is the probability of getting a red ball when you pick the two. So whenever you take 2 balls randomly, what is the probability of getting 2 red balls directly? Okay, so this is easy because we have already solved the problem before. So now listen here for the first two one. You just have to first total the number of balls that is there in the bag. That is 5 plus 3 is equal to 8. Now what is the possibility of getting a red? So P, possibility of getting a red ball, possibility of getting a red ball is nothing but 5. There are 5 red balls. There are 5 red balls. So out of 5 red balls, we are selecting 2 balls. And there are totally 8 balls in the bag, out of which also we are selecting 2, which means totally we are only taking out 2 balls, and those 2 balls should be red in color. Fine. Now solve this 5C2. Now the formula for combination is n factorial divided by n minus r factorial into r factorial. So 5C2 is 5 factorial divided by 5 minus 2 factorial into 2 factorial, and for 8C2 it is 8 factorial divided by 8 minus 2 factorial into 2 factorial. So 5 factorial is 5 into 4 into 3 factorial. 5 into 4 into 3 factorial. Don't just write it as 3, divided by 5 minus 2 is 3 factorial into 2 factorial, divided by 8 factorial, sorry, 8 factorial is 8 into 7 into 6 factorial, divided by 6 factorial into 2 factorial. So here you can cancel 3 and 3 factorial. Here you can cancel 6 and 6 factorial. So 5 fours are 20 divided by 2 factorial is 2 into 1 whole divided by, okay, 7 eights is 56, right? 7 eights is 56. So 56, okay, where did the cursor go? Yeah, 56 divided by 2 into 1. So 2 ones are 2 twos are 4, 16, 2 eights are 16, again 2 ones are 2 tens are. So therefore you get 10 by 28. Understood? That is how you get 10 by 28, not directly like this. Did you understand the calculation? Yes or no? Okay.